Hi guys, so today we are going to be doing Module 2 lesson over Chapter 9, Geometric Figures. So let's start out by talking about the different types of angles. There are complementary angles, which are angles that add up to be 90 degrees, supplementary angles, which are angles that add up to be 180 degrees, and similar triangles, which are angles that have corresponding angles and or equal corresponding angles and proportional sides, but are not always the same sides. So let's begin with question 1. For question 1, we have to demonstrate the relationships between the measures of angle 1 through angle 12. So let's start out by finding the measurement of angle 7. So we see this triangle right here with angle values of 63 and 61, and then angle 7 right here. The sum of the measurements of a triangle, or the angles of a triangle, equal 180 degrees, which means we would have to do 180 minus 63 minus 61, which equals 56. So that means angle 7 is equal to 56 degrees. We see that angles 1 and 7 are corresponding angles, which means they are equal. So angle 1 is also equal to 56 degrees. The angle opposite of angle 2 is vertical with angle 2, which means they are equal. So that must mean that angle 2 is also equal to 63 degrees. Angle 3 and the bottom left angle of the triangle, this one right here, shown as 61, are corresponding angles. So angle 3 is also equal to 61 degrees since corresponding angles are equal. The angle opposite of angle 4 is vertical with angle 4 and has a value of 61 degrees. So that must mean that angle 4 is also equal to 61 degrees. The angle opposite of angle 5, which is angle 1 with a value of 56 degrees, is vertical with angle 5, which means that angle 5 is also equal to 56 degrees. To find angle 6, we see that angle 6 and this angle right here of the triangle are supplementary angles. Supplementary angles are 180 degrees. So that means we would do 180 minus 61 to get the value of angle 6, which is 119. So angle 6 is 119 degrees. Angle 8 and angle 7 are also supplementary angles. So to find angle 8, we would do 180 minus 56, which equals 124. So angle 8 is equal to 124 degrees. The angle opposite of angle 9 with a value of 61 degrees is vertical with angle 9, which means that angle 9 must also equal 61 degrees. The angle opposite of angle 10 is vertical with angle 10, which means that angle 10 must also equal 119 degrees like angle 6. Angle 11 is vertical with angle 8, which means that angle 11 is also equal to 124 degrees like angle 8. So last but not least, the angle opposite of angle 12, angle 7, with a value of 56 degrees, is vertical with angle 12, so that must mean angle 12 is equal to 56 degrees. Now let's go on to number 2. For number 2, we have to demonstrate how to find the measures of angles 1 through angle 8. So first we see that angle 1, C, and B make up our triangle and is equal to 180 degrees. So we would have to add all 3 of those angles together to get 180 degrees. So we would do 74 plus angle 1 plus 26, and we would figure out that angle 1 is equal to 80 degrees because 74 plus 26 plus 80 equals 180. Next, we extend the parallel lines of our triangle to find corresponding angles. We see that angles 3 and 8 correspond to angle 1, which means that angles 3 and 8 must also be 80 degrees since corresponding angles are equal. We see that angles 2 and 3 are supplementary angles, which means supplementary angles add up to be 180 degrees, which means that angles 2 plus angles 3 equals 180 degrees. So angle 2 plus 80 equals 180. So angle 2 must equal 100. We see that angles 5 and 3 are alternate interior angles. So angle 5 is congruent with angles 1, 3, and 8. Therefore, angle 5 is also equal to 80 degrees, like angles 1 and 8. We see that 7 and 8 are supplementary angles, which means they add up to be 180 degrees. So that must mean that angle 7 is equal to 100 degrees because 100 plus 80 equals 180. Angles 4 and B are corresponding angles, which means that angle 4 equals B, which equals 26. So angle 4 is equal to 26 degrees. We see that angles 6 and C are also corresponding angles. So that must mean that angles 6 and C are the same. So that means angle 6 is equal to 74 degrees. Now for question 3. So for question 3, we have to figure out the angles of this n-gon. So first we have to know that the sum of any n-gon is n minus 2 times 180, n being the number of sides. So if we count this polygon right here, it has 8 sides. So we would substitute the value of n, which is 8, into the expression n minus 2 times 180. So 8 minus 2 times 180 is equal to 1080 degrees. So after that, we have to set the sum of the measures of the interior angles equal to the value of the sum of the measures of the interior angles and solve for y. So we would add up all of these angles together and set them equal to 1080, and that ends up being 54y equals 1080, and 1080 divided by 54 is equal to 20, so that means y equals 20. And after this, we would substitute the value of y into the expression to find our 3 different angles, 3y, 7y, and 12y. So for 3y, we would put 3 times 20, which equals 60. For 7y, we would do 7 times 20, which equals 140. And for 12y, we would do 12 times 20, which equals 240. So our angle measurements are 60 degrees, 140 degrees, and 240 degrees. Now let's go on to number 4. So for number 4, we have to find the interior angle measurement, the exterior angle measurement, and the central angle measurement. So we first have to know the different formulas to find these angle measurements. So interior angles have a measure of n minus 2 times 180 divided by n. Exterior and central angles have the same formula, which is 360 divided by n. So we first have to count the number of sides of our shape, which is 9, and that equals n, or n equals 9. So we have to substitute n equals 9 into the formulas for each type of angle to get our measurement. So let's start out with the interior angle. So we would substitute 9n for n, and n minus 2 times 180 divided by 9 is equal to 140. So our interior angle has a measurement of 140 degrees. Next, we substitute 14n for n, the formula for the exterior angle. So we would do 360 divided by 9, which is 40, and we would do the same for the central angle, which is equal to 40. So now we have all the measurements of our angles: 140, 40, and 40. Now let's go to question 5. For question 5, we have to construct a cube with the vertices A, B, C, D, E, F, G, and H. For part A, in a different color, we have to construct vertices D, E, G, and H, which are the vertices of a tetrahedron inscribed inside the cube. So let's do part A. So this is part A. A tetrahedron is also called a triangular pyramid, and this is our triangular pyramid with vertices D, E, G, and H. For part B, we have to construct 3 of the faces of the tetrahedron, D, E, G, H, as subsets of the faces of the cube, which means that the tetrahedron that's inside of the cube has none of its faces in the planes of the faces of the cube. So now let's do part B. This is our new tetrahedron. Oops. And here is part B.